Okay, this is your lesson for Monday, November 2nd, and Wednesday, November 4th. So hopefully you've been getting through the Newton's first law practice problems with the free body diagrams. We also introduced you to Newton's second law on Thursday and Friday. So now we need to talk about Newton's third law. You will have a lab over third law today. And then on Thursday and Friday, you will work on Newton's third law practice problems. So let's go ahead and talk about Newton's third law. So you probably learned Newton's third law as for every action, there's an equal and opposite reaction. There are a lot of confusions with that. So let's talk about third law. Okay, so to recap, all forces are interactions between two different objects. Okay, a force can't act on just one object at a time. It has to be an interaction from two objects. That is, we have to have the feeler, that's the one feeling the force, and we have to have the dealer, that's the provider of the force. Okay, if you can't identify a feeler and a dealer, then that force is not present in the situation you are studying. So let's talk about Newton's third law. Okay, like I said, all forces are interactions between two objects. So the rules for Newton's third law are these. Your first rule is the Newton's third law force pairs are found on two different free body diagrams. So every force has a feeler and a dealer. You're going to find the force pairs. One force will come from the force diagram for the feeler in one situation, and it will come from the dealer's free body diagram on the other situation. So what you will notice with Newton's third law force pairs is that they are equal in magnitude. And remember, magnitude is a word for size. Okay, so whenever we say magnitude, we are talking about size. So they are equal in magnitude or size, but opposite in direction. So if I were to pull on a rope to the right, the rope pulls back on me with an equal force to the left. One of the force pairs would be found on a free body diagram for me, and it would be the rope pulling me to the left. The other force pair would be found on the force diagram for the rope, and the rope would be being pulled to the right by me. So another way to identify Newton's third law pairs is that the feeler and the dealer are reversed. Okay, so what exactly does that mean? Well, let's do an example. Okay, so we're going to have our little person here, and he's going to stand on the surface of the earth. Okay, he's a giant. Okay, we can draw a force diagram for the person, and we can also draw a force diagram for the earth. So our first force diagram for the person is going to have two forces on it. If he's standing at rest, it's going to have the gravitational force on the person by the earth. And it's also going to have a normal force on the person. Ooh, that end was ugly. Normal force on the person by the ground or the earth. You could say it that way too. Okay, if I'm drawing a force diagram for the earth has a pull from the person in the opposite direction. Remember, we talked about this though. It is like that because it doesn't move when you fall. The earth doesn't come flying up to you because of the large mass for earth and the very small acceleration it feels. So if we go back to the equation of the gravitational force or weight, where it's mass times the gravitational field strength, the gravitational field on Earth is equal by the person is equal to the gravitational force on the person by the Earth. So it's because of the smaller, you have a very small gravitational field around you. So for Earth, it would have a gigantic mass, tiny field strength from you. You would have a tiny mass, but feel a large gravitational field strength from the Earth. The other way you can identify these force law pairs, so they are equal to each other, but we look for this on the person by the Earth, and then we go look for the force pair, which has the feeler and dealer reversed. So my force pairs here are the gravitational force on the person by the Earth and the gravitational force on Earth by the person. So whenever you're trying to identify third law pairs, it's going to be, there's one more rule we skipped, the same type of force. So let's squeeze number 4 in here. It's going to be the same type of force. So if it is a gravitational force on one force diagram, it's going to be a gravitational force on another force diagram. We could go down here and we could do a force diagram for the ground. And the force diagram would have that normal force from the person because it's a surface-to-surface interaction. But that would be on the ground by the person. So that would be my third law pair here to go with this normal force on the ground by, or on the person by the ground. So again, same type of force. They're both normal forces. They have to be the same size. And the feeler and the dealer are reversed. Okay? All right. Go do the lab activity. And if you still have questions, please let me know. Have a great day.